Hello, I'm Alif. I will explain about my final project, which topic is local metric dimension of circulant graph. First, let me introduce some preliminary attribute and notation basically related with graph theory. Suppose we have a graph G and suppose a set W is a subset of the set of all vertices in G, says like this. Let's note that code U, V, W is written like this. Defined by a vector distances between vertex V to W. This is for example. If we have a pair of vertices in G, which their code are not sum belongs W, then we say W is a resolving set. From our previous result, we have W is a resolving set. For a question, is there another resolving set Wxn such that its size is less than size of W? The answer is yes. We can check that for this set, which is Wxn, and so we have another resolving set. For a minimum possible resolving set Garnierita of the graph G, we define that this is metric dimension of G, noted by dim G. A set W subset of set of vertices in graph G is a local metric set of graph G if a pair of vertices U and V adjacent, we have code UW is not equal to code VW. From our previous slide, we have W accent are also a local metric set of graph G above. Let's take a look for a biverted graph, for example below. We have a local metric set is only one vertex. At previous slide, we already defined about metric dimension. We also have a dimension of local metric dimension that is analog, which is minimum possible local metric set cardinality of G, that is noted by LMD G. Okay, for my further result, I will use circulant graph, which defined here. At this right side is an example of circulant graph with parameter 1, 2, 3, and with order 8. Here is some useful theorem about local metric dimension. For first, if J is non-trivial connected graph of order n having L1 through 3 through twin equivalent classes, okay, I will explain it later, then LMDG is greater than or equal n minus L. For second, the graph G is non-trivial connected graph of order n, then LMDG is equal to n minus 1 if and only if G is complete graph with order n, and LMDG is equal to 1 if and only if G is bipartite graph. And the last one, we have a connected graph of G of order n minus is greater than or equal to 3 as a local metric dimension n minus 2 if and only if this clique is equal to n minus 1. Thus, we already have a process of graph with LMD 1, n minus 1, and n minus 2. Okay, it's some notes for the true twins before is defined clear here. Consider any pair of vertices U and V in G is pair, say, true twins. If there is another vertex in G, say vertex X, that is not equal to U or V, this is adjacent to both U and V, and also U and V are adjacent. If we have U and V are not adjacent, we say this pair is false twins. Furthermore, two twins produce an equivalent relation on a set of vertices in G, which means there will have some equivalent classes. We name U1, U2 until UL. Okay, this is my main research, that is finding a general formula of local metric dimension of circular graph with parameter 1 and 2 with generalized order. Here is some example of LMD of circulant graph with order or size of vertex 5, 6 until 9. Okay, that is my introduction of my final project. Thanks for watching.